Chapter 5, Example 5. The table below shows the results of the top 3 competitors in a recent 3-event competition. Each placed first, second, and third in an event. Who should get the gold medal? Okay, so each person had a first, second, and a third place finish. So you might naturally think that they're all even. There's a tie. 3 gold medals. But we know we don't really award those in the Olympics. There's always a winner in the individual events. So we've got to have a way to account for this. This is where the z-score, one of your best friends in this course, comes in. We're going to use it over and over and over again. And the z-score is found by the formula you've found from your reading, which is z equals x minus x bar over the standard deviation. A lot of times you're going to see it written as mu. But remember that mu is if we know the true mean. And usually we don't. We just know from a certain experience. We don't know what it is overall. So we use x bar when we don't know the true value. The calculations are the same, it's just keeping that in mind. We'll talk about parameters more in detail later. Okay, so that's what we're going to be using to find these. We want to know the z-scores. Before we do that, if you notice, 100-meter dash, 10.1 seconds, 9.9 seconds, they're all measured in seconds. Great, easy to do. Shot put, that's all measured in feet. 66 feet, 60 feet, 63, mean of 16, standard deviation of 3 feet. Okay, however, the long jump, we have 26 feet, 27 feet, 27 feet 3 inches. Then we have a mean of 26 feet and a standard deviation of 6 inches. So the units aren't the same. Let's go ahead and convert all of these feet into inches. It'll just make life easier when we do some calculations. So this is going to be 26 times 12, because there's 12 inches in a foot, and we get 312 inches. Okay, 27 is just 12 inches more, so 324 inches. Okay, we're adding 3 more inches for the next one, so 327. And we already found out that mean would be 312. Okay, so here's what's nice. The standard deviation tells us how unusual a score is. So the more unusual it is, the better that performance was. So if we take the standard deviation from each event and add them all together, that should tell us who had the best performance. There is one other trick to this. Shot put, throwing it further, is a positive. So a positive z-score, if you're over the mean, more standard deviations above it, that's a good performance. Long jump, the longer we jump, the better. So if you jump further than the mean of 26 feet and get a positive z-score, that's good. The more positive it is good. If you jump below 26 feet, that's a short long jump, you would get a negative z-score, which is bad. It's taking away from your score. However, the 100-meter dash, we want a faster time. You want the time to be lower than the mean. So in this case, a time of 9 seconds would be much better than a time of 11 seconds. So a negative z-score is actually good. But if we're adding the z-scores together, a fast time would subtract from it. So I want to take the opposite. I want to take the negative of the first z-score of the 100-meter dash. So let me show what I mean. I want to do negatives in the 100-meter dash because a negative time is actually a good. It's a positive. So I'm going to start with competitor A. I'm going to put a negative in front of this, and then I'm going to find out the z-score. Now my data point, the time that first person ran, was 10.1 seconds. The mean run time is 10, and then I divide by the standard deviation, which is 0.2. Okay, that is for the 100-meter dash. And I want to add all the scores together. So I'm going to add the success on the shot put. So that's going to be 66 minus the standard deviation of 60 divided by the standard deviation, or minus the mean of 60 divided by standard deviation. So I get divided by 3. And then finally I'm going to do the long jump, which is 26 feet. Sorry, we changed that, right? So let me use what we changed. That's the whole point. 312 inches minus the mean, which is 312 inches, divided by the standard deviation, 6 inches. This comes out to be 10.1 minus 10 divided by 0.2, and the negative, that's going to become negative 0.5, 0.5. Did some pretty basic math there. Calculator if you need to. 66 minus 60 is 6. 6 divided by 3 is 2. So I'm going to add 2. And finally, 312 minus 312 is 0 divided by 6, 0. So the first competitor has a score of 1.5. Overall, their performance was 1.5 standard deviations above the mean for these 3 events. Respectable. Let's see how the other competitors fared. So competitor B, they had a really fast run. This is the one that got first place. So 9.9 minus 10 over 0.2, and we said that has to be negative because a negative score is actually good, plus 60 minus 60 over 3. So we're going to see right there that that one's just going to become 0. Had a pretty good long jump performance. So 324 minus 312 over the standard deviation of 6 inches. So we get positive 0.5 plus 0 plus 2, which is 2.5. So far, it looks like competitor B would be first place, A would be in second place, but we haven't calculated competitor C yet. So let's do C. Now C had a really slow 100-meter dash. So we're going to put that negative in front. We're going to have 10.3 minus 10 over 0.2. Again, I'm just using the information on each category. Then I have 63, so they did a longer shot put than competitor B, minus 60 over 3. And they had the longest long jump, won that competition. So that's the 327 minus 312 over 6, standard deviation of the long jump. And this gives us negative 1.5. So that slow 100-meter dash has a big impact. It's way worse than the slightly slower one for competitor A. 63 minus 60 is 3, divided by 3, that's 1. And then we get a 2.5 for that really good long jump performance. Unfortunately, that negative 1.5 really brings things down. Negative 1.5 plus 1 just gives us a negative 0.5. Take that away, we get 2.0. So it would appear that competitor B would win, C would come in second, and third would get the bronze medal. So we want to write that out to actually answer the question in a complete sentence. Competitor B has the more unusual overall score. And we'll add some extra information in here. Didn't ask for it, but it's not kind of something that can get you into danger by mentioning it. Competitor C would earn silver, which is second place, and competitor A wins the bronze. Now, we've got to be careful sometimes about writing too much, because we can do the problem all right and then overwrite it. We can just accidentally mention something that's wrong or not very clear and lose points. But in this case, that's pretty obvious. There's nothing wrong with that, and I think it's good to include that extra information so that you can show you understand those scores just beyond who wins overall.